A and AS level mathematics. Lesson 21, and we're going to return to sequences and series, and this is part 8. And we're going to be reminding ourselves what is meant by a sequence, so what is a sequence, and also remind ourselves what is an arithmetic progression. And then we'll move on to what is a geometric progression, finding the nth term, which we write like that, of a geometric progression, and find the sum of the first n terms of a geometric progression, and find the sum to infinity of a geometric progression. So first, let's remind ourselves what a sequence is. A sequence is a set of numbers or objects made and written down in order to some mathematical rule. So in other words, we could start with 2 and have the mathematical rule of add on 5. And we keep adding on 5, and this would be a sequence. Or we could start with 2 and keep doubling it. In other words, multiply by 2 and multiply by 2 and multiply by 2. This would be a sequence. Or we could have a mathematical rule where we start with 2 and we treble it and add 1. Treble it and add 1, treble it and add 1, and so on. So a sequence is a set of numbers written following some mathematical rule. Now an arithmetic progression, as we found before, is a sequence, but it's a particular sequence where each new term after the first term is made by adding a constant amount to the previous term. In other words, we start with 2 and we add something on like 5, and then we add the 5 on again, and then we add the 5 on again. As long as we add on the same value each time, we'll have an arithmetic progression. We could add on a negative number, so here we add on -2, add on -2, add on -2. As long as we keep adding on the same value, it could even be a fraction. It can be positive or negative. But as long as we add on the same value each time, we'll have an arithmetic progression. The amount we add on each time is called the common difference. The first term is denoted by U1, and we call that A. The first term is always A. And we can explain an arithmetic progression by using that statement and this statement. And this statement describes what is happening. The next term is the previous term, add on the common difference. Now let's introduce the geometric progression, GP for short. Well, yes, this is a sequence, but this time the special sequence is each new term after the first term is made by multiplying by a constant amount to the previous term. In other words, we could start with 5, multiply by 2, and multiply by 2, and keep multiplying by 2. This would be a geometric progression. Or we could start with 50 and multiply by a half, and multiply by a half, and keep multiplying by a half. As long as we start with a value and keep multiplying by the same value, and that same value is R, and that's called the common ratio. As long as we start with a value and keep multiplying by exactly the same value, we will get a geometric progression. So let's just look at a few more examples of geometric expressions. Start with 1 and keep multiplying by 2. That means to say R is 2 each time because I keep multiplying by 2. And A is the first term. Or we could start by 100 and keep multiplying by a fifth. Multiplying by a fifth is the same as dividing by 5. So if I keep multiplying by a fifth, I'll have a geometric progression. Let's multiply this by -2. Multiply this by -2. Multiply this by -2. If I keep multiplying by the same value each time, I will get a geometric progression. And the value that I keep multiplying it by is denoted by the letter R, and it's called the common ratio. So in this case, the common ratio is -2 because I keep multiplying by -2. Now let's look at finding the nth term, which we denote by UN, of a geometric progression. Now remember, the first term is always a, and I'm going to multiply by a common factor, and we'll use the letter r for that. So I'm going to keep multiplying by the value of r. So a geometric progression can be written like this: a, now you multiply that by r, now you multiply that by r, now you multiply that by r, and you keep multiplying by r. There is a general way of writing down a geometric progression. Now this is the first term, this is the second term, this is the third term, and so on. And you'll notice that the power in each case is one less than the term. So therefore the nth term is going to be a multiplied by r to the power of 1 less than n. That is the nth term of a geometric progression. A, which is the first term, multiplied by the common ratio, the same number that you're multiplying by each time, 1 less than the value of n. So let's use that piece of information to write down the fifth term of this geometric progression. As you notice, each time it's being multiplied by 2. So if it's being multiplied by 2 each time, r is 2. A is the value that we started with. Therefore un, which is the term we started with, multiplied by r to the value of 1 less than n. So if you're wanting to write down the fifth term, then that's going to be a, which we now know is 3, multiplied by r, which we now know is 2, raised to the value of 1 less than the 5. 2 raised to the power of 4 is 16, so 3 16s are 48. So the fifth term of this geometric progression is 48. Because we're only looking for the fifth term, let's just check that we're right then. Double that, double that, double that. Double the 12, get 24. Double the 24, we'll get 48. Yes, it's working. Let's work out the sixth term of this geometric progression. So we're starting with 30. We're dividing by 5. Well, actually, we're dividing by minus 5. And that's the same as saying multiply by minus a fifth. So r equals minus a fifth. So if we multiply this by minus a fifth, it'd be coming back to a plus, and the 6 divided by 5 is like that. So we're starting with a as being 30. We're multiplying each time by minus a fifth. Therefore the sixth term we can find by using the general term for the nth term of a geometric progression, and say that the sixth term is therefore a, which we know is 30, multiplied by r, which we know is minus a fifth, raised to the power of 1 less. Several ways of doing this on your calculator. I'm actually going to change this to being 0.2. So I'm going to type in minus 0.2 raised to the power of 5, and I'm going to take that answer and then I'm going to multiply that by 30, which will give me this answer. That could have been done other ways. I could have used the fraction button.